Alright, let's discuss 5.4, change of variables. Let z be a function of two independent variables x and y. Okay, while x and y also have their own functions, right, being denoted as u and v. Okay, so if we want to find a derivative of z in terms of u or z in terms of v, this is how we are going to do it. We are going to conduct chain rule. Okay, so first let's look at one example, and later we'll try to do the exercise. So if you can see this, z is equal to the exponent to the power of xy. Okay, and each of these x and y also have their own function inside it, which is x equal to 3u to the power of 2 and y equal to 2u plus v to the power of 3. And they want us to find the partial derivative of z in terms of u and z in terms of v. We can't really find it directly because our function here is in the terms of x and y, and u and v is actually inside x and y. One way is to substitute x, the function of x, and the function of y inside this function. You can do that. However, it might at some functions, that idea might be troublesome. Your function will be complex, right? So another way is by using the idea of chain rule. Okay, so to find the partial z over partial u, right, we will use the idea of chain rule, where we know that we have the information of u in two other functions, or two other variable, which is x and y. So we should have the chain rule of x and the chain rule of y toward u. Okay, and now that we have this, we can look for the partial of each of this derivative. Okay, and then just substitute it and get the answer. The same goes for partial z over partial v, where you'll need to conduct a chain rule of x and y toward v, substitute it, and obtain the answer. However, that will not be your final answer. This will not be your final answer, because this question asks you to give the derivative of z in terms of u. Currently, we only substitute it, we only conduct a derivative and end up in terms of x and y, right? So that's why the next step is to substitute all of the x and y into u and v, so that we will be able later have the answer in terms of u and v. Okay, so let's look at exercise 5.4 and try to apply the idea of change of variable, right, in this exercise. Alright, question number 1. Let z equal to x squared plus y squared, where x here is equal to this r cos theta and y here is equal to r sin theta. And they want us to find the partial z over partial r and partial z over partial theta, not partial z over x or y. So as I said, one way is to substitute the x and y functions into these functions. So later we are going to have r cos theta and r sin theta here. That can be applied if you have a simple function. Alright, so just substitute it. This is not chain rule, by the way. This is the alternative way if you have a simple function. So substitute the x and the y and just expand it, right? Factorize it, and Pythagoras theorem cos squared theta plus sine squared theta is equal to 1. So that will leave us with r squared. So z equal to r squared. And next, to find partial z over partial r, we'll just find the derivative of this. So you will get 2r as the answer, right? Of partial z over partial r. And for theta, we don't have any theta variable here. So the derivative will be equal to 0. There you have the answer there. But this way can only be used if you have a simple function like this. If the function become more complex, it is not efficient to use this way. Hence, we have a chain rule to be used. Right? Now let's discuss chain rule. Okay, so let's redo it. We know that x equal to r cos theta and y equal to r sin theta. And to find partial z over partial r, right? Because we have two variables here, we need to conduct a chain rule for two variables of x and y toward r. Okay, so let's find each of this. So partial z over partial x is 2x. Partial x over partial r, right, will give cos theta. Partial z over partial y to y, partial y over partial r sin theta. So next, substitute it in the formula of chain rule. Okay, and this will be the answer after we conduct a chain rule. But still, please bear in mind that this is not the final answer, because still this answer is in terms of x and y, right? We want it in terms of r. So to do that, we'll need to substitute the x and the y here, so that we'll have this function inside, right? So substitute x and y, alright? So expand it, factorize it, and we have the Pythagoras theorem, which is equal to 1 here, and that will give us 2r as the final answer. The same idea can be applied in finding partial z over partial theta. Okay, so just find all of the partials, derivative, and substitute it, and expand, substitute the x and y, right? Expand them, and you should get 0 as your final answer. Okay, now let's look at the second question. Let z equal to this function, or we don't know what is the function. However, if you substitute, if you conduct the partial derivative, this is another terms for partial derivative, right? Fx and fy are partial derivative with respect to x and y. Okay, so this is the partial derivative of this z over x, and you substitute the x and y with 4, you'll get 7, right? We don't know the function, but we know if we conduct a partial derivative and we substitute the x and y with 4, you'll get 7. And for partial derivative toward y, and you substitute 4, you will get 9. That is what we know so far. Okay, however, they give us the function of x and y. So this is the function of x, this is the function of y. So find the partial z over partial t at t equal to 0. Okay, so basically we know that this function is in terms of x and y, and the function inside x and y is in terms of t, and they want us to find the partial z in terms of t. So we're able to apply chain rule here. As usual, to make things easy, let's put everything, extract every information, right, so that it will be a lot more clear for us. So this is the function unknown, and if you input 4 into x and y partial derivative, you got 7 and 9. This is the function of x and y, and they want us to find this at t equal to 0. So we know that this is the we can be solved using chain rule. So apply chain rule. Okay, we have the chain rule for x, chain rule for y in terms of t, and let's look for each of this information. Right, we know that the partial derivative of z toward toward x will give us 7. The partial of x over partial of t, right, we're able to find it because we have the function. So find the function of x over partial x over partial t, and then partial z over partial y. We don't know the function, but we know that if you substitute it, you will get 9, right? And then partial y over partial t, where we'll be able to find it using the function, the given function. And next is to substitute everything in the chain rule, right? This chain rule. Substitute everything inside it. Okay. And I expand it. Simplify it. And they want us to give this where at t equal to 0. So just substitute t that you have in this function. Alright. After substituting it, calculate it, and you should get this as your final answer. So that is how you conduct chain rule, right, in finding the change of variable using partial derivative. Thank you.